All right, ladies and gentlemen. Today we are going to learn one of the three key things that you will learn in algebra. Solving quadratic equations. Okay, so let's write solving quadratic equations. Please be advised, a full set of notes for today's lecture will be available on ogmath.com. All right, so you'll have the YouTube video, and then you've got OG Math if you like to look at a written version. Okay, so solving quadratic equations seems hard, but it really isn't. So we're going to write down, the very first thing we're going to do is we're going to take our notes. What we're going to create is a list of steps. I think I've got 8 of them, 7 or 8 steps, depending on how you count. And we're going to write the steps out, and then we're going to turn the page and have those steps on their own page. Okay, don't lose that page, because you're going to be turning back to that page several times throughout the year. Okay? So here are our steps to solve a quadratic equation. Step 1. Step 1, here we go. You got to start somewhere. We'll start with step 1. Step 1 is to make sure everything is on the left side. And by that, I mean that the right side should say equals 0, okay? So a lot of times with these problems, before you can start doing the problem, you have to move some terms over to the left side before you can start, so that the right side says equals 0, okay? And by left and right side, I mean left and right of the equal sign. Step 2. Rearrange terms to get in standard form. What is standard form? Here's standard form. AX squared plus BX plus C. That's standard form. Where A, B, and C are some numbers, okay? They can be positive or negative. They can be fractions. Doesn't matter. They're just they stand, A, B, and C are something.
Wait,
all right?
It says to what?
Say what?
It says to what? Rearrange terms to what?
Oh, get in standard form. Rearrange terms to get into standard form. By the way, not all of these steps will be required for every problem. As we'll see, some of the steps are done already, and you just kind of skip past it. Okay, step 3. Factor out the GCF. GCF stands for greatest common factor. Again, if we find out that the greatest common factor is already 1, we know there's nothing to factor out, we can skip that step. It's possible, and you'll see it on the first problem, that we skip all these steps. Okay? All right, step 4. Factor the left side. There's one thing I want to add to step 3, or kind of sandwich in between 3 and 4. Actually, here's what I want you to do. Somewhere in here between step 3 and 4, we'll put it here. We'll write and identify A, B, and C. All right. It's important that we actually write out what they are, because you're going to need those multiple times during the problem. Okay, so those are our 4 steps so far. Now we're going to factor the left side. Okay. And rewrite equation in factored form. Here's what I mean by factored form. I mean, we're going to go from ax squared plus bx plus c into something that looks like this. X plus or minus some number m times x plus or minus some number n. This is factored form. This is standard form. So importantly, these two forms are equivalent. You're just changing the form. What you're doing is you're going from a trinomial. See, look, here's one term, then a plus sign, then another term. That's 2 terms, then a plus sign, then a third term with the c. That's 3 terms, so we call it a trinomial. You're going to, by factoring, you take a trinomial and you make it into 2 binomials. See? 1, 2, that's 1 binomial, then 2 binomial. Bi means 2, tri means 3, okay? So that's the purpose of factoring. All right, step 5. Set each factor equal to 0. Set each factor equal to 0. Step 6. Solve both tiny equations. Step 7. Write answer. Let's use the correct language here. It's the solutions. Write solutions properly. Okay, properly. We'll talk about what properly means, okay? There's like a lazy way to write it, and then there's kind of like the math, ogmath way to write it, okay? Now, one little warning. Step 4, where we actually factor, this has its own set of steps. We did it last week, but we did it when I was gone. And so we'll go over it. When we get to that part, we'll have to write a little tiny mini recipe for factoring, okay? But only have to do it once. Once we get it down, we don't have to write anything. Now, you're looking at this list of steps, and you've got to be thinking, if this guy really thinks he's going to sit here and do these steps for like 20, 30 problems, you got another thing coming. But let me explain something. I've been saying this all day long, and it's been fairly well received, okay? I can make an equivalently ridiculously complicated list of a recipe for how to make a peanut butter and jelly sandwich. All right? I'll show you what I mean. Say, carefully approach the closet door where you keep the peanut butter. Place your hand on the handle of the pantry. Turn the knob. Pull the door open. Reach into the pantry and remove the thing of peanut butter. Rotate the lid counterclockwise 3.5 times until the lid comes off. Insert knife into peanut butter. You see how ridiculous? Spread evenly on bread, right? It's silly, right? This is what the same thing. I've listed out every little tiny step in a ridiculously detailed way, so that when you are struggling, you can refer back and see exactly what you need to do next. Okay? That's the purpose. Okay. So let's do an example. Let's do an example. Solve. Solve x squared plus 4x plus 4 equals 0 for FOR x. Solve x squared plus 4x plus 4 equals 0 for x. All right, well, you got the recipe. I don't. I just have this little tiny piece of paper. So what's the first step?
Make sure everything on the left side.
Okay, so do we already have the first step done?
Yes, sir.
Okay, let's move on to step 2. What's the next step?
Rearrange the terms for standard form.
Okay, so let's check. Here's standard form. Ax squared plus bx plus c equals 0. Is it already in standard form?
No.
Yeah.
Yes. Okay, this would be a good time to write out what a, b, and c are. Okay. What's the number sitting in front of the x squared? 1. What's b?
4.
4. What's c?
4.
4. Good. Now what's the next step? This is when we're on the greatest common factor step.
Factor out the GCF.
Factor out the GCF unless it's already 1. So let's look at these numbers. This is one of the benefits. This is one of the 3 benefits of writing out a, b, and c like this. The GCF of 144 is 1.
Yeah.
So it's already 1, therefore we can skip that step and move on. Next step. Hey, please help her stay awake. This is really important. This is not working today, okay? All right, next.
Back to the left side.
This is it. If you weren't paying attention until this moment, this is when you need to wake up, because now we're going to factor this. So come over here, and make some kind of mark that you indicate that we're gonna do some side work, okay? Now, this is what I was talking about. This is the subroutine called factoring. When you're solving quadratics, you have to do this subroutine called factoring. So this first problem, we're gonna write it out in meticulous detail. And then after that, we won't have to do it, okay? So step one, compute the master product, which I'm gonna abbreviate as MP. The master product equals A times C. Now, this is reason number two why I had you write out what A, B, and C are. Because now you don't have to think, do you? Just plug it in. That's A is 1 times C is 4. So the master product is 4. Okay, so I guess I should label this as step 1 of the factoring steps. Here's step 2. Factor the master product. Okay? In this case, the master product is 4. So we're going to create a factor tree for 4. What I need, and I need y'all to shout it out. 2 and 2? Okay, so I need numbers that multiply to be 4, and I heard 2 and 2. Please don't forget about the evil twin. -2 times -2. Okay, because that also multiplies to be 4. What else? Yeah, we call that the trivial case, okay? 1 and 4, that's called the trivial case. It doesn't mean it's stupid or something, it just, that one comes automatically. Negative, it's like the game that ships with the console, okay? -1 and -4, okay? So you need to have all these written out. Now the next step, I bet you remember it. What's the next step? Add. Step 3 is add each factor pair. Okay? Let's do it, guys. Put plus signs here and equal signs here. Okay, so we're going to add now. What's 2 plus 2?
4.
How about -2? Okay. 1 plus 4? And -5. So with these, it's pretty simple. It alternates positive, negative, okay? Now, the next step, what is it? Does anyone remember? Step 4. Circle the factors. Whose sum equals B.
That's equal.
B is 4. So it's the first row, right? Okay. Circle them. Now, I can't ever remember, did we put write in factored form in these notes, or are they part of our factoring subroutine? I wrote it right in factored form, right? On what is that in our steps? What step are we on where it says write in factored?
It says rewrite in factor.
Rewrite in factored form, okay? So that's what we're gonna do up here. So we come back up here and we do an open parentheses, close parentheses. Open parentheses, close parentheses, equals 0. Now, there's an implied, but not stated, multiplication between those two parenthetical expressions. And in here, we're gonna put an X, and here we're gonna put an X. And now what you do is you copy and paste these factors with their signs, okay? Both of these signs are pluses, okay? We copy and paste them over here, so it's +2, +2. You are so close to victory, you gotta be able to taste it at this point. So don't get ahead of yourself. What's the next step? Well, read your recipe.
Oh, set each factor equal to 0.
Set each factor equal to 0. So just so we're clear, this is a factor and this is a factor. There's two factors for every quadratic. There's two. So we're going to set this one equal to 0, x plus 2 equals 0. And look at this one's identical, x plus 2 equals 0. Let's go through the motions of doing this for both of these, what we're going to do next, even though they're the same thing. This is the one that I was telling you about last week. It's called a double root. The discriminant of this quadratic is equal to 0, which means it has one double solution. Okay, and that's what you're actually seeing that happen right now. Okay, so now read the next step.
Solve both tiny equations.
Solve both tiny equations. So what's the only thing I need to do?
Solve for it.
Yeah, solve for x. How do I do it? Just minus 2 on both sides, right? Yeah, what's going on is people are shouting out the actual answer because it's such a trivial step. But still, we want to show our work, and it won't always be this simple. Okay? So I've got x equals -2 and x equals -2. It's very important that you label these as x1, that's a subscript, x sub 1, and x sub 2 to indicate, hey, I've got two solutions, folks. I've got solution 1 and solution 2. Now, the very last step is my hobby horse. It says write the answer or the solution properly. Here's what I mean by that. This is fine. If you wrote this out, x equals -2, x equals -2, I would give you 100 for this problem. But here's how you'll have to write it when you get into Algebra 2. So you might as well start writing it in Algebra 1. Let's just start doing it correctly. Open curly brace. What this means the set of all. The set of all. And then we're going to write an x, because that's our variable. The set of all x. It looks like code, right? And then put this vertical line. That line means such that. The set of all x, such that. And then write x, and then put a colon. And this means contains, like a container, okay? You're listing the contents of a container called x, because this container has more than one item. And we write -2, comma, -2. And then we, like a code, like HTML or anything else, we're going to close the curly brace to finish it off. So let's read this sentence out loud and see why mathematicians prefer things written this way. The set of all x such that x contains -2 and -2. Okay? So when you learn what this all means, it makes more sense to write it like this. So it means that the x variable contains two elements, -2 and -2. Now hold that thought, hold it right in your mind, where we're at right now, because boy, do I have something cool to show you right now. All right, watch this. I've got Desmos pulled up here. Now here's the beautiful moment. Go back to our board. Look at our solution set. -2 and -2. We called it a double root, right? Come over here and click right here. Look at that answer. -2. That's what we found. And so here is a big, huge thing. All right? This is a big, big thing. Big leap. Please write this down, okay? This is a very important thing. The solutions to quadratic equations are simply where the graph crosses the x-axis. Okay, big, important point. What this means for you, and the reason that's so important, is because when you're doing the STAR test, they give you this. All you've got to do is type it into Desmos and go click where it crosses the x-axis, and you're done. You don't have to do all this work, okay? You see how fast that would be? What would it take me, like 10 seconds? So, just so you know that that's there for you, okay? Now, we're gonna do another problem. Can I erase this? Okay. We'll go much faster this time. I promise it'll go so fast. You'll tell me to slow down, it'll go so fast. Stay focused. This is an important day. We don't have many days like this, so stay focused for me. Hey, I would just be glad that you're getting your money's worth in this class. The teacher's up front teaching, you're learning things. All right, no worksheets or word searches or mazes, word finds like these, waste of time. All right, here we go with example number 2. We're gonna have to go quick. Solve x squared minus 9x minus 12 equals negative 4x minus 6 4 FOR x.
Make sure everything's on the left side.
Yeah, make sure everything's on the left side. So the very first thing we need to do is just plus this stuff out. Like, we'll just plus out the 4x. And I need to make sure I write it underneath its matching terms. Plus 4x. Well, look, that cancels that. Now, can I do the same thing here? Plus 6? That would reverse that operation. Cancel. Over here, plus 6. Now, let's draw lines here, here, and here. Okay? Put your equal sign. This is a 0. All right, now you got 0. And this x squared just comes on down. We didn't touch him. What's negative 9x plus 4x? Negative 5x. Good job. Negative 12 plus 6? Negative 6. So the state of the problem is x squared minus 5x minus 6. Now, this is where you could stop and plug it into Desmos. You would go y equals that, and you'd erase the equals 0. Okay? Just so you know that that's where you'd exit this process. But you'd have to do this part first. You understand? All right. So now, what's the next step? Greatest common factor? Rearrange term. Okay, rearrange terms. It's already in standard form. Next step? Greatest common factor?
GCF.
GCF of 1, negative 5, and negative 6 is 1. we better identify A, B, and C so we don't leave people behind. What's A, B, and C?
A is 1, B is 5.
-5. And -6. Don't forget that sign, folks. Okay, so the GCF is 1. We go to the next step. Factor, right? The big step. This is a big step. So come over here. Yeah, we're going to create side work, compute the master product. That equals A times C, which equals 1 times -6, which equals -6. Now, factor the master product. I need two numbers that multiply to be -6. 3 and -2, and its evil twin, -3 and +2. What else? Two more. How about trivial case? 1 and -6 and -1 and +6. Now what? Add. Right? Okay. Add. Equals. What is 3 plus -2? Normal people would say it's 1. 3 minus 2 is 1. What's -3 plus 2? -1. Folks, you're dropping negatives, okay? So be careful there. -3 plus 2 is -1. 1 minus 6. And -1 plus 6. Right. Now, what we need to do is circle the factors whose sum is B. So who are my factors? My factors are 1 and -6. Circle the sign. Now, write in factored form. Come back here. Open parentheses, close parentheses. Open parentheses, close parentheses. Equals 0. X. Write the factors. X plus 1. X minus 6. Next step. Set each factor equal to 0. X plus 1 equals 0. X minus 6 equals 0. Now solve each of these trivial example problems. -1 on both sides, x equals -1. Plus 6 on both sides, x equals +6. Now write it like an adult. The set of all x, such that x contains -1 and 6, close brace. You're done. Now, let me make sure that you have this connection in your mind to what is going on graphically. I'll let everybody finish writing, but that was fast, right? That was pretty fast. I bet we were under 4 minutes.
No.
Okay, now I'm going to go. Can I go? Okay, I'm going to go to Desmos now. Okay, I'm going to go delete what was in there before. Who thinks this is actually not that hard? Now, I need this, x squared minus 5x minus 6, okay? Y equals x squared minus 5x minus 6. Now, I'm going to go over here and click where they cross the x-axis. So, -1 and +6. -1 and +6. Go back to your math problem and look at your answers. They match, right? -1 and +6? So that's the correlation. It's the x-intercept of the graph that crosses in two places. That's the solution to the quadratic equation. You understand? Say it back to me. The x-intercept of the graph is the solution to the quadratic equation.
The x-intercept of the graph is y. I haven't said it in the race.
The x-intercept of the graph is the solution to the quadratic equation.
The x-intercept of the graph is the solution to y.
Great job, guys. Thank you so much. What a great crowd. Fantastic work. Appreciate everything that you do. Thank you.